We're going to start, so please be seated. And I wish you all a very good morning. So this is the web technology class on web science, and I am not Jacco, nor am I Diana. So my name is Victor de Boer. I'm a researcher and a professor here at VU. And I'm actually in the same research group as Jacco van Osselbrugge and as Diana Samuelo, who you've met, I hope. They asked me to give this lecture. So I was involved in this web technology class for the past few years. And I asked whether I could keep doing this lecture because I think it's really nice. And I'll give you a bit of context. So like I said, I'm in the same research group as Jacco, and that means that we do similar research. And I think one of the things that we would answer if you ask us what kind of research is we have in common is that we all research something that has to do with the web. So that means that it's something that you can actually do as a scientist, and that there is such a thing as web science. And this is a relatively recent realization, so some of the sciences are much older, right? You can imagine that, I don't know, history or literature or astronomy is much older. Web science is a relatively new science. That means we're also sort of figuring it out. But in the next, let's say 2 times 45 minutes, I'll try to argue that we think that this makes sense there's a need for web science, and it's a new type of science, right? It's a new thing. So it's not just mathematics or computer science, it's actually something more. And I'll give you, let's say, a brief overview of how people have been thinking about web science, but also I'll give you some examples of research that we are involved in at the global scale. Some of these slides are by Guus Schreiber, so you might recognize the name. He's the current dean of the faculty, and he also used to be involved in this type of research. All right, so without further ado, this is what we're going to talk about, like I said. So first I'll talk a bit about what is web science, what do we think web science should be. And then we'll go into some examples on why, and hopefully that shows why we think that this is a new type of science, because we can look at what people do on the web. So already that gives you a hint that it's not just about computer science, it's actually about understanding how human behavior on the web works. And then the second half, I'll be going a bit more in detail in 3 specific web science topics. So one is net neutrality. Hopefully you've all looked at the article on net neutrality. But we'll also be looking at linked data, which is a research area that I've been involved in for the last few years. And a new thing that's popped up recently is the idea of using linked open data for this re-decentralization of the web. We'll get to why this is needed and what it is later on. So hopefully that's interesting. Okay, so hopefully you know who this guy is. Is this the first time you see him? Who is this? His name is on the right. Maybe it's too small. He invented the World Wide Web, the technology that you're now studying. Tim Berners-Lee, thank you very much. Okay, so he'll be popping up a lot because he actually is, you could tell, one of the first web scientists. But he also is very much involved in current research programs and businesses around the web. So there's a bunch of pictures there, and you can make a little game, and every time you see him, I don't know, you get a point or something. So as you might or might, I hope that Jacco showed you this picture on the right here. This is the original proposal for the World Wide Web in 1989 that Tim Berners-Lee wrote to get a little bit of funding to get this thing started while he was working at CERN in Switzerland. Right, and I'm not sure if Jacco told this, but in the top you see the little scribble that his boss put on the document. It said, vague but exciting. Right, so that was the birth of the web, as you know. So it's only now 30 years old, is this correct? Yes. So it's not that old, and we have the guy who invented it is still with us. So it's a thing that has not existed for a very long time. But you could say it's now it's grown into this arguably the most important information architecture or source of information in the history of humankind, right? So if you want to be grotesque, we can say those kind of things. But anybody you talk to, they would not deny that this is an important thing with a capital I, capital T. And we can look at how its importance, right? So this is one graph that you can draw of the influence and the usage of the internet, which is mostly what they mean here is World Wide Web. Since its inception, so here's 1991, and it goes up all the way to 2018. And you see all these lines going up, and each of these lines indicates some form of influence of specific types of web use. So the internet is the blue line, and we have smartphone use, which is the red line there. Yeah, so we see all kinds of historical trends that this thing is still growing. Right? So it's not like a thing that was invented and it was done and we can look at it. Now it's not. It's still gaining in influence. And what I always like is you can hardly see it now, but if you look very carefully here, you see a little sort of dip, right? And this is the dot-com bubble. So this was around 97, 98. So I'm not sure if you remember, but this was when we were all thinking, oh, this internet thing is not nothing anyway, right? And we thought it was nice. But all these companies invested in it, and they all went bankrupt. And then we thought, okay, this just was a fluke. It was a bubble. And now, only years later, we can see that actually it was just a minor hiccup in the, say, unstoppable growth of this this thing that we call the World Wide Web. Right. So to put it in perspective, is that this thing is growing. It's gaining in influence on a global scale. I think hardly anybody in the Netherlands has not in some way interacted with the World Wide Web. We started earlier, we go on longer, and I think all of you here, of course, are doing it. But this also at the global rate global scale is gaining a lot of influence. Right. So this growth is exponential, and has not stopped yet. So that's one reason why we might think we need to understand it, right? It has such a big impact on society and on everything, and we'll give you more examples later, that we need to understand what it is and how it works. And you've been doing that here, right? So you've been looking at the technologies that make it work. So if one answer to the question, what is the web, is to point at the technologies that make up the web, right? So this is HTML, the URIs, HTTP, even going even to the pipes, TCP/IP, and the cables that make up the World Wide Web. That's one answer to the question, what is the web? And that's sort of the level at which you've been studying it now. But web science realizes that this is not the only thing that is the web. The web is actually also the phenomena that happen on it. Right? So that's the cat pages that are there, and the social networks, and the canvas pages that you will use. So this profound influence, not on the technical level, but at a societal level. And web science agrees that there is some sort of interplay between these things, and that's the thing that we need to study, right? So it's not just the bits, and not just the clicks, but it's actually what people do online. So this is there's a need for a new type of way of looking at this, which is what you could call a systems-oriented view, right? A more holistic view on the web and its ecosystems, including the internet and any mobile technologies, that both acknowledges both the technical and the social components. So that is what web science is. Right? So it's this important thing that we need to study in new ways. So this is mirrored in the many definitions of web science, and this is just one, which is the one that probably is most read, which is the one on Wikipedia, which says that web science is the study of the social behavior on the web. So this is this sort of behavior layer at the personal, organizational, and societal level. Then it's the technologies that enables it, right? So the HTTP, etc., and it's the interactions between the two. And I think one of the lenses with which you can look through it is to look at the web as a socio-technical system. And socio-technical systems are a very new way of looking at certain phenomena. Okay, so you can have other lenses, or let's say frameworks with which you look to things. So this is a much more user-centric view that is the designed by web scientist Stefan Stab, who's in Germany. So he looks very much at what people do, right? So he's more interested at the social layer. So what do people do? How does their behavior, individual behavior, give rise to these social processes, right? So this is sort of sociology on the web. And he also researches how you can actually sort of interact with these streams to get some insights in how people behave socially. Right? So actually in the master we have a course called Social Web, where you do this as well. So you use web technologies to study social behavior of humans. This is another way of looking at the web. This is, let's say, a more graph or mathematical way of looking at it. This is a visualization of the web that was made at some point when it was still small enough that you could actually do it. Right? So the web has grown to a size that now any, let's say, sensible algorithm has a very hard time on crawling everything and getting everything nicely visualized. This was one of those visualizations that proved to be very insightful because it's not this homogeneous blob of links. We actually see these bright spots there. Now, we'll get into detail what these bright spots are and what they mean. Right, so like I said, it's a social technical system, but it's also slightly different from these other sciences that I've been telling you about, right? So the astronomy, right? We study something that looks a lot like this. If I would show this to anybody, your first guess might be that this is the solar, like the Milky Way or something, right? Or the night sky. It's actually the web, but you could part of web science is looking at this and figuring out what it looks like, right? And that's very much like what an astronomer would do. An astronomer looks at the object of study, or a biologist, right, looks at the object of study, and then tries to understand it and how it works. Right, and that's part of what we do. But the nice thing about web science is that it's not the only thing we do. Because these technologies, like the web, is not some, let's say, natural thing or a God-given thing that we can only study. No, it's actually the thing that we can change. Because we web scientists are also engineers. Right? If we see something that doesn't work or doesn't work properly, we fix it. So all these technologies that you've been studying, they've been designed to do certain things, and sometimes it works, sometimes it doesn't work completely, and then we make a new version. Right? HTML5 is the 5th version of HTML because we saw that there were things that were not working exactly as we hoped, or there were new things that we wanted it to do, and then we just redesigned it. So that's quite nice because you can't do that with, of course, with the Milky Way, right? So you can only study it. So it's a very actionable thing. And the human body, I would say, most of the time you can't really change stuff unless you go into sort of cybernetics and build better humans. Right? But it's in web technology, it's very easy to come up with new technologies, and we'll show you a bunch of examples where we're doing that. This is a very famous view on web science. This is the additionality principle. So this says that web science is not just computer science with the web as your main object of study. So I happen to be a computer scientist who is interested in the web, but there's other people that come from different fields, right? So there's sociologists, there's legal scholars, there's political scientists, media scholars that all study the web and what people do on it, right? So it's not sort of just using one thing, but it's actually having different views, this sort of system-oriented view on one object. And you need to have these different views to get an understanding of what the web actually is, how it works, and what we can do about it to fix it, if it's broken at all. Right, so this is sort of it's a bit megalomaniac, so the web is everything, but it's important to understand that it's not just computer science. Even though we are here, like you, all of you are approaching it from a, let's say, computer scientifical, information scientifical perspective. Right, and this is also mirrored in the article that you looked at. This birth of web science, right? This 2007 is when people started realizing that we might need to study the thing that we've built, right? So it was by then already existing for around 17 years. And in the beginning it was of course not so impactful, right? So the exponential growth has a slow start. And then at some point people started thinking, oh wait a minute, this thing is actually, it's taking off. We might need to understand what's actually happening. So around 2007 is when people started thinking about this idea of web science, and this was the article, I think, that sort of coined the term. Where they also, they agree that there's some socially embedded computer science or studies, and the need to move from just studying the technology, studying the chips, to studying what people do, studying clicks, as they call it here. So that's around 2007. And then that's the same time that the Web Science Conference was started. And then 10 years later, there was 2016. You see that actually this community had grown. It's not just that we as scientists think, anything we study everything, right? It doesn't matter, there's someone who's studying it. Actually, there's also big interest from big players in the field, such as Google, who were interested in understanding this web better so that they can build better services, right? So there's a sort of an interest from commercial partners there as well. And then 2 years later, this was, you were not yet here at VU, but I was, and actually the Web Science Conference was hosted here at VU. And the guy in the middle is again Tim Berners-Lee, and he gave the keynote lecture there. Actually, he gave his Turing Award lecture. So the Turing Award is the Nobel Prize for computer science. Tim Berners-Lee won it for the invention of the World Wide Web and its technologies, and he gave the lecture that you're supposed to give here at VU. So we were very honored, and the whole aula was full. So you know the aula upstairs, right? I've never seen it full since I've been working here, except when Tim Berners-Lee was giving a talk. So this was a big thing. And there was a nice conference around it here, where we talked about all kinds of issues. So this is a picture that I took. So this is, he was again sort of hammering that this is something that we need to understand. So Tim Berners-Lee, if you've seen some of the latest videos, he's very much aware of that what he's built has this impact, and that maybe this impact is not exactly what we all want. And he's sort of trying to solve it, trying to fix it. He didn't say, okay, this was it, I just made it, you guys screwed it up. No, he said, okay, maybe I have a role to play in this thing. And that's right, so to build systems which lead to people being constructive. So this hopefully mirrors what you've been seeing in the past few slides. Okay, so let's have a few looks at web science. So one of the early attempts was to figure out what this thing actually was looking like, right? So the astronomer looking at the sky. And one way of looking at the web is to approach it as it is, as a mathematical graph. Right? So graphs have nodes and links. Okay, the web has pages and links. So can we maybe paint a picture of the web as a graph? So people have been doing that, and they've been doing this from very early on, figuring out what the web looks like. Right? Networks can take many different shapes and forms. So for example, you have these exponential networks in which there are nodes that have some arbitrary number of links to other nodes, and this is sort of randomly distributed across the network. Right? So every network has, let's say, on average, every page has on average 10 links. Then there is some distribution that determines how many links there are to and from a page. That's an exponential network. You get something like this, which is scaled. Right, and we get these scale-free networks, which are different types of networks. In scale-free networks, we know that they're not equally distributed. We know that there are some nodes that have a lot of incoming and outgoing links, and there are a lot of nodes that have very few incoming and outgoing links. So this is a different type of network, and you can measure any network and just sort of measure what kind of shape it takes. There are other types, but these are the two, let's say, most common ones of complex networks. Right, and then we found out that the web is this thing, right? Because actually these light spots that you saw in this sort of space picture that was actually the web are these so-called hubs. Right? So we know that there are pages that get referred to a lot and refer back a lot. Right? And these are the pages that you would expect. For example, Wikipedia. If you make a page about your cat, and your cat is this super nice special breed, right? So you want to have your readers know what breed it is, you probably put with a link to the Wikipedia page about that cat breed, right? So why would you point to someone else? Most likely that's the most valuable information. And everybody does that, that's the problem, right? So now Wikipedia becomes this hub in the web. And there's a lot of pages that are not linked to, or have very few links, so that you see them on the outside, on the outskirts. Right. So this is the form that the web takes, and another view of the same thing is like this. So there's a lot of nodes in the middle. Actually, there's not a lot of nodes in the middle that are, let's say, the center of the web, and then there's all these incoming and outgoing links. Maybe the best one is this. This is actually a mathematical representation of the in degree, so the number of incoming links to a page, a web page. And on this axis you see the in degree, and on that axis you see the number of pages, and this is on a log scale. Right? So you see a straight line, and what it means is that you have, let's say, this is pages that have very little incoming links, like 1 or 2. So there's a lot of them, right? 1 to the power 1 times 10 to the power 8. Let's say a lot. Right? And there's a few pages that have actually a lot of incoming links. So this is 100,000 incoming links. Right? So this is again this Wikipedia page for the cat breed. You can open it. Right? And you see that there's a very nice straight line that goes down, which means that there's an exponential distribution between the number of inlinks and number of pages. Right? Which is not something that is necessary for every graph that we make, every network that we make, but apparently this is what the web looks like if you let the technologies roam free and let people do whatever they want. Right? And why does this happen? So there's a few theories. One is the theory of preferential attachment, and that is the thing that if something gets attached to a lot, so I think that gets referred to a lot, then actually that makes that page more interesting, and then more people start referring to it. Right? So there's sort of the winner takes all type thing, and that's one of the reasons why this occurs. So you can do these measurements, and these measurements are already a bit older, because as the web is growing into billions and trillions of pages, it becomes harder to draw these things, these conclusions. Okay, so I'm not sure what's going wrong here. So do you know who this guy is? Oh, that's there. So he's not Tim Berners-Lee, that's one hint. Yeah? Kevin Bacon, and Kevin Bacon is an actor, right? He's not a web scientist, but he's been used for all kinds of things. Let's see if we can do this, play this thing.
Our target, Barbra Streisand. Now, using movies that are currently showing on Entertainer, let's link Barbra up with Kevin Bacon.
Yeah, do me.
Okay, Barbra Streisand was in A Star Is Born with Gary Busey.
This is not you.
Who was in Lethal Weapon with Danny Glover?
Shut up!
Danny Glover was in Silverado with Kevin Kline. This is the good stuff. Who was in Dave with Kevin Dunn?
You can't kill the president.
And Kevin Dunn was in Stir of Echoes with, you guessed it, Kevin Bacon.
Whatever door you open in my brain, I want you to shut it.
What's more, all of these films are on Entertainer right now. So check them out and play along yourself. Entertainer.
Okay, so this is also an ad. Right, so what you see here is a sort of frantic 10-second explanation of the 6 degrees of Kevin Bacon principle. And that's the theory that Kevin Bacon is the center of the universe, or at least the center of the Hollywood universe. Because he is sort of this center in the network of actors, where a link between actors is if they play the same movie. Right, so this was sort of a silly game at first, and then people started taking it seriously and looking at the mathematical properties of this thing. Turns out that Kevin Bacon is actually not the center of the universe, but he's sort of among the top 20, let's say, most central figures. So I think Barbra Streisand is actually quite more central. That being said, he got his name attached to this principle, right? The idea that any actor is, let's say, only 2 or 3 steps away from Kevin Bacon. And you think 2 or 3 steps, that sounds a bit weird. So what if I take a Dutch actor, for example, right? Even maybe a lesser known one. But even if you do that, there's a nice service online. If you go to what's it called, 6 degrees of Kevin Bacon.org or something. You can actually play the game. You enter an actor, and you will see that it's extremely difficult to find an actor with 3 or more steps from Kevin Bacon. Right? Which is sort of counterintuitive. You would expect there's tens of thousands of actors in the world, so surely there must be this weird I don't know, Polynesian actor who is more than 10 steps away from Kevin Bacon. But that doesn't happen that way. And actually we know that this principle has been studied before by sociologists who also found that actually most of us here are only 6 handshakes away from anybody else in the world, right? So for example, let's say that you shook hands with someone, maybe that person shook hands with Jacco, right? So Jacco is, even though he's not the center of the universe, he knows other people in the United States, and this guy is probably shook hands with this other person, and then we end up with a student somewhere in rural West Virginia. I don't know. Right, so there's only 4 steps between you and this student in West Virginia, and then you can imagine that it's not a stretch to think that everybody in the world is more or less 6 handshakes away from each other. And this is a phenomenon that's called the small world phenomenon. So even though there's a lot of different nodes in this network, the shape of the network with its hubs, right? So there's people that shook a lot of hands, let's say I don't know, President Obama or Premier Rutte. Right? So we are probably all connected through the handshake that the two of them exchanged. So this small world phenomenon is a phenomenon that you get in these scale-free networks. And there's other scale-free networks. So this is another one. So this is a social network. Actually, this is the social network that was extracted from Facebook from me a long time ago. Right? And there again, you see the same principle. So you see this idea of preferential attachments. There are these natural hubs that draw together the network into a very tight ball, so to say. And what we did is we measured this ball, the depth of this ball, at some point when the web was still only 800 million pages large, which was really the web in its infancy. And there you can see that what we did then is we just measured the whole thing, and the diameter of the web is not 6, so it's not as tightly connected as the social network, but it's quite small. So the average diameter is 19, right? The average length of the shortest path between 2 pages. You can make these calculations. So these are mathematical formulas that you can apply to this object of study, the web, to study how it compares to other networks. And this tells us also a little bit about what people do on the web. Right? So here's a technological means to derive social or practical conclusions. Let me just make this full screen. There we go. Okay, so this is the sort of the conclusion of that. The web is not a random network, but has a form that emerges from its use. So it's not just that any web that ever has been designed will always get this, or that it's a feature of the technologies. No, it's a feature of what people do. Who builds the web pages? How are they built? What kind of tools are supporting this? And how, for example, do search engines work? Right? They work because of these links, which means that people will use that knowledge to link their pages to other people's pages. Okay, so let's have another look, and I'll show you some examples on, let's say, how society is influenced by technologies and vice versa. And then we'll do that for a few examples, and then we'll go to a break. So one obvious one is business, right? Economics. I think any economist now is sort of looking at the models that we have about supply and demand, for example, and reevaluating them in the light of the web, because the web has changed how business is done on the global scale. So 2 examples. So one is the prevalence of online music platforms. And this is not even streaming. I think the iTunes is before, let's say, the prevalence of streaming. But with streaming, this has changed a lot. And there's a lot of people that are frantically looking at what are correct business models for streaming services. Right? And those that get it right, they make a lot of money. Right? So one example is, in the olden days, before the internet, if you are a music producer, you are always looking for the next Madonna, right? Or Justin Bieber, or whatever you kids are listening to. Right? So we're looking for the big thing. Because why? Printing CDs or records is very expensive, and so it has a lot of startup costs. So I need to make sure that I print the right number of records and sell them all, and make sure that everybody likes the same music. because then I'm making money as a record producer. Right? So that was the whole business model and the whole marketing model. So in the world of streaming, actually what we can do is we can just put everything that ever existed online, because it doesn't matter. It doesn't matter that everybody likes Madonna or everybody likes Justin Bieber, because I'm actually, everybody here has their own little music taste, and it costs me exactly the same thing, which is nearly nothing, to get that stuff to you. Right? So it's just a little hard drive space and some bandwidth, which is almost nothing. So that means that suddenly my business model becomes from focusing just on this, let's say these most well-known bands, to making sure that I can effectively deliver the long tail to you. So is it the term long tail, has that appeared before? So anytime you have these Zipf-ian distributions, these exponential distributions, right, you have a few things that have a lot, right? For example, a few things that have a lot of links, but also a few bands or artists that have a lot of fans. But you have a lot of things that have very few fans. And these used to be economically uninteresting. Right? And now they're economically interesting because actually this is bigger than this, because this goes on for a very long time. So how does iTunes make money and how does Spotify make money is by ensuring that you can listen to your favorite local super weird underground band. Right? Because it doesn't cost them anything to add that to their platform. So that has completely changed the music business, and it's completely changed, let's say, the business models that make music work. And it took a little while to get used to this, so there was a lot of money being lost in the music industry, and now you see actually that the music industry is doing fine, so you shouldn't worry too much about it, right? Because they are adapting to this reality. So that's one, and the other one that I always like a lot, and I never found a link, so I can't be 100% sure if it's true, but never check a blue story. So this is a special type of car. It's from the 1950s, right? So this is a dinky toy car, little metal cars, and they are very popular. Were in the 50s, and of course now you have people sort of collecting them. Apparently the axles of the wheels break easily, right? So you have all these axles that are breaking. And there was a mailman in the UK who had a method of making these little axles. So he was making them for his own collection. But through the web, he got in contact with all these other Dinky Toys collectors, and everybody was getting interested in his axles. And he could actually, set up a little platform. He was selling them and sending them all over the world. And at some point, he quit his job as a mailman, and now he's a full-time Dinky Toys rear axle building as his job. So, and I like to think that before the web there was a room for exactly 0 Dinky Toys axle builders in the world, and now after the web there's at least room for 1 Dinky Toys axle builder, right? Because even your small business can operate on a global scale, which is something that can only be done through the web. And so this is sort of 2 examples of how business marketing has changed. And again, we're still figuring it out. So that's business. So there's another maybe interesting thing is politics. So this is, I think, on the news constantly. So the impact of specifically social media on politics is sort of, people are still being shocked by that every day or every year. And I think the first really election where people realized that the web played a huge influence was the 2008 one from where Barack Obama won. So Barack Obama, he was campaigning against what's his name? I forget his name. Anyway, the other guy, he was not doing so well on the web, so he was not sort of pushing all of his efforts on the web. And Obama had an ace social web team that realized that actually where you get most of the money and most of your supporters is not in this top thing, but it's in the long tail. To reach all these people that are maybe interested in voting for you, maybe interested in donating a little bit of money, that's where you get your election from. So he was much more successful in that, and the Democrats won that year, as you might remember, because he was president in the good old days. And of course, Republicans are not stupid, so they upped their game and they actually outplayed on the social website the Democrats last time. So it's not the only reason they won, but it's a very important one. Yes.
You think we have the best part in front of us or behind us?
That's a very good question, and I hope I can give you an answer at the end of the talk. So I'll show you that, so this is bad, right? Or there's bad things happening here. And people like me and Tim Berners-Lee and most people are very skeptical about what's happening, and we are seeing if we can do something about it. So maybe that's a positive fisting. So that's a good question. I hope that you get a little bit more answer at the end. Right, so just to show you a bit about how much effort and emphasis they put on the social website. So the team from Trump ran about 75,000 variations of Facebook ads per day, variations to measure the impact of those ads and to increase them. So this was all done automatically, of course. So this is the biggest, they call this biggest A/B testing ever. Constantly measuring what's the impact of my ads, how can we improve the ads, and just sort of go 100% for these social media platforms. Right, and this is the quote from the digital director of Trump's campaign, Brett Parscale, who claims that basically Facebook and Twitter were the reason they won. And you see now that there's a big backlash against this, and Facebook and Twitter, two of the large, let's say, players on the web, they are re-evaluating their role in this thing. Right? So Twitter has banned political ads, Facebook has not banned political ads, so they're struggling. Right? And what we can do as scientists is at least point at evidence and say, this is what happened on the web. This is how we can actually investigate these things, and then either through political pressure or through, let's say, corporate responsibility, maybe change how it works. Okay, so journalism has changed. This is very related, of course, to politics. But let's say journalists used to be this, they call it the fourth estate. So let's say these powerhouses of the democracy. The only way that you can get trusted information or information at all about anything. Right? So this is a very much sort of top-down approach where you would get your news from either the newspaper or the news channels. And of course that has completely changed. So it's no longer the case that there's journalists and non-journalists. There's now all kinds of in-between things. We have bloggers, we have influencers, we have people just reporting the news live as it's happening through all kinds of online services. Right? And people from the journalism profession, they are struggling with this. What's their role? Is it now just a gatekeeper or a curator, or are they, do they have to provide commentary only? So this is a big question, and we see that increasingly a large part of the news intake that average people have in the world is through online media. And again, this changes how we perceive reality in some way. And understanding how and what it means and what it does to us is also part of website. So no small questions, and also not very obscure, right? So this is stuff that you also see in the news. Talked about. Right, fact checking is now a thing. That's maybe a good thing. So also to be a bit positive about this, right? So we can now fact check what journalists are doing. We used to not be able to do that because we could never get to the data or the original recordings or whatever. And now we can actually check whether what's being said is done. And people are doing this, right? And again, this is happening in the long tail. People that have a little bit of extra time, they invest it to the benefit of all. But this is also still a struggle. So journalism is changing. Governments are changing, right? So after people get elected, they have to also actually govern. And how the government interacts with its citizens is greatly changing. Right, so if you do anything in your local municipality, you're usually doing it through an online form of some kind. And governments are really experimenting with ways of doing that. So just a quick anecdote before we break. This is the City Hall of Zoetermeer in Second Life. So who of you has a Second Life account? None? So who of you knows what Second Life is? Yeah, so 6. So Second Life used to be what people thought would be the next variant of the web, right? So it was this idea of a virtual reality world, and there was a time where people thought, okay, this web with its HTML pages and its links, that's actually a very unnatural way of interacting with information. So a much more natural way is if you have a virtual avatar that can walk through a physical space and go to different points in this virtual world to do things that you might want to do. And everybody was thinking, this actually makes sense. So, I mean, making fun of Zoetermeer now, but the VU, they completely built this campus, including these lecture halls, in this virtual reality world. They spent thousands of euros on it. And they were actually doing these online lectures in virtual reality. And then you were all sitting there at home, of course, but now in your virtual reality avatar, and looking at my virtual avatar, and I was sort of doing this from the comfort of my home. Which, you know, it's not a stupid idea, but apparently it's not really the thing that we went for. So, you know, Zoetermeer was the first Dutch municipality who had tried to move its services to a virtual city hall, and they stopped doing it in 2009. So it turned out to not work and just be silly. And actually, the web with its links and pages works quite well. Right, but let's say governments are figuring out how to interact with their constituents. Okay, so this is the last one I'll do before the break. This is one that I participated in. It was very interesting. We had a minor for a while, which is called Web Science. So we did Web Science in that minor, and there were people from all over the VU that were using the web for their studies. And there was one student, Fabian Eichelboom, and he was actually a bachelor from the theology department. And he was interested in how people pray online versus offline. Right? So very VU-ish topic. And it was very interesting because we thought, that's actually an interesting question. Maybe that, you know, prayers change if you do them online or offline. So there was he focused on two platforms where you actually leave prayers. So you could actually leave a prayer card. And he compared that to an existing database of physical prayer cards. And then sort of tried to categorize them, figure out what it was doing. So it's a bit hard to see anything, but you can see that offline prayer, the most of the big blue block on the left is that most people ask for health-related things, or they are interested in health-related things. There's open intentions, there's something about death, in general, conflict, disaster, etc. So you can make this nice graph about how people pray offline. And here actually you see that online prayers are much more about other things. So about personal growth, for example. What else? Health is also still a big one, right? But there's a slight difference. So you see actually that online environment changes how people do their religious business. So this is an example. This is a very nice type of research that we actually published at this Web Science conference. It's a very, let's say, question that asks, how does X change if we do it on the web? So that was quite nice. And so this is my closing slide. This is the latest installment of this Web Science conference. And what I've just done is I listed the different sessions. Right? So these are the topics that are being discussed at this Web Science conference, which this year was in Boston, Massachusetts. And you see that it's mostly not about the technologies, but it's about, you know, the phenomena. Right? So what do we have? Fake news. There's two whole sessions about fake news, non-human actors, and misbehavior. Right? So this is how can we fix the bad things. And then there's user behavior, for example, emotional well-being. So you can see that they're actually really about these phenomena and how we can use the web to study these things. Okay, so that's it for the first half. Then in the second half we'll start looking at we'll look at three in more details: and net neutrality, linked open data, and Solid, which is a linked open data solution for some of the web's problems. So I'll see you in 15 minutes.